Asthma, pathophysiology. The airways of asthmatic patients are invariably reddened and swollen, suggestive of acute inflammation. Inflammation in asthma is largely driven by immunoglobulin IgE-dependent mechanisms, and a marked increase is observed in the numbers of lymphocytes, mast cells, and eosinophils, and activation of macrophages. While T lymphocytes release numerous cytokines, fibroblasts, endothelial and epithelial cells also contribute to the chronicity of the disease. On degranulation, the mast cells localized on airway epithelial and smooth muscles release multiple inflammatory mediators such as histamine, leukotrienes, prostaglandins, bradykinin, platelet activating factor, and chemotactic factors for eosinophils and neutrophils. This results in acute bronchoconstriction, edema resulting from increased capillary permeability, mucus hypersecretion, and accumulation of eosinophils and neutrophils, which are the typical pathophysiological changes observed in asthma. Inflammation results from cellular proliferation in the smooth muscle and mucous glands, where an increased deposition of matrix protein is observed, along with thickening of basement membrane and angiogenesis. Thus, chronic inflammation invariably leads to structural changes in the airways. This is induced by smooth muscle dysfunction that leads to bronchial hyperactivity, hypertrophy, hyperplasia, and release of inflammatory mediators. Inflammatory mediators in asthma include lipid and peptide mediators, chemokines involved in the selective recruitment of inflammatory cells from the circulation, cytokines that amplify and perpetuate the inflammatory process, and growth factors. Environmental factors have more influence on whether an atopic individual develops asthma than genetic factors, although several genes have been identified that influence development of atopy. Genetic factors play a role in the severity of the disease and the amplification of the inflammatory response.